So is this screen visible?
Yes, sir.
So last day we have introduced three different coordinate systems like Cartesian. Then second one is was cylindrical, and third one is spherical. These three were introduced systems. So Cartesian systems, it is any point that can be represented by, suppose it is P, so it can be represented by XYZ. It can be represented by XYZ. Cylindrical, any point, it can be represented by R phi Z. R phi Z, and spherical can be represented by R theta phi. So this part, where this part of three coordinate system till this point, till these aspects were discussed in the last class. So diagrammatically, if we say Cartesian, it is XYZ. So it is simple. It's the vertical distance, horizontal distance. So basically, the classic example of a Cartesian system is a wall or in a room, maybe. So where you have three pairs, you can treat them as a classic example of classical Cartesian system. In the second case, in the system, this is X, this is Y, and this is Z. So if this is P, so it is R phi Z. So what is R? We have projected one point on XY plane. That means in on this plane. That means on this plane we have projected our point P. Okay, this was our XY plane. So we have projected one point. Okay. So this one is the projected point. So you line joining that origin to that point is R. Angle between positive x-axis to R is phi. This is R, and Z is the vertical distance as it was in the case of Cartesian system. This is Z. And what was spherical system?
Sir, hello.
Yes.
Sir, someone is trying to join, so please accept him.
Okay. Sorry. So in case of spherical system, it is R theta phi. So we directly connect origin to that point, it is R, Angle between positive z-axis to r is theta, and again for the same way, we if you draw a projected point, then angle between positive x-axis and to the line joining is phi. So definition of phi is same as that one in case of cylindrical system. So this was our initial discussion based on the previous class. The definition of three coordinate systems, and how a point in a given system can be transformed into another. That was also discussed. So I am not going to that. So now also we have discussed about if you keep one variable constant and other two remains variable, so it will generate three linear planes in case of an Cartesian system. uh, in case of an Cartesian system, we generate three linear planes. In case of cylindrical system, we have generated two linear planes and one non-linear planes, or one curved planes, that is a cylinder, and the curved plane that will generate as a cylinder. Okay, and in case of a spherical system, we have generated one linear plane and two curved planes. So we have seen that uh, we have started from linear plane, all linear planes, then the degree of linear plane will reduce. Then we have come across two linear planes and one cut planes, then one linear plane, finally one linear plane and two cut plane. I have also mentioned this fact is that it is not end. Beyond this, a lot of coordinate systems are there which are actually utilized in the space. Now, with respect to Earth, the space is a huge distance, which is with respect to that large distance, everything seems to be non-linear. So, so whatever spaceships or rockets that were sent to the spaceships are is a matter of non-linear calculations. Okay. Now, this is not the end. So apart from these three, lot of coordinate systems are there. So the immediate question comes now: if today any one of you or anybody, uh, if today any one of you and anybody else will generate a new coordinate system, or will come with a conception of a new coordinate system, let us say XYZ is our reference frame, and let us say someone has come with a conception of a new coordinate system, let us say alpha beta gamma. Alpha beta gamma. So these three are, let us say, new points in a particular coordinate system. Okay, so this is a new coordinate system. Let us consider someone has come with this conception. Alpha beta gamma has got a different definitions, new definitions. So the first and foremost question is that now whether this coordinate system will be a valid one or not. What is the guarantee that these three discussed in the previous day, uh, whether all those three were valid coordinate systems, whether rest of the coordinate systems are valid, whether this proposed coordinate system, if anybody comes with the conception of this coordinate system, will that be a valid one. Now, to validate a coordinate system, to validate a coordinate system, three conditions needs to be checked. Three conditions needs to be checked. What are they? Uh, Number one, the planes. Okay, let me write in this way. The number one condition is the planes must be orthogonal to each other. This is the condition number one. Planes must be orthogonal to each other. Planes means these three planes, respective these three planes. So respective these three planes must be orthogonal to each other. Okay. So these respective three planes are generated. They must be orthogonal to each other. Okay. So these three planes, respective three planes must be orthogonal to each other. Now one example to this, you must observe that three walls. So if you consider any two walls and floor, any two walls and floors of a room, you can observe that these three surfaces are uh, orthogonal to each other. What do you mean by orthogonal? Orthogonal means 90 degree to each other. It is lying 90 degree to each other. Okay. Any questions on this?
No, sir.
Okay. Now in this online mode, I cannot I cannot make you understand how these two, in case of cylindrical and in case of a spherical, how these three planes will be orthogonal to each other. I cannot make you understand. So if it is a offline mode, I can do that. I used to do that in every year. However, from previous years, I this is the limitation of the online class. I cannot make you understand. Okay, even if you uh, okay, even if you can see me, even if you can see me, I cannot make you understand. Okay, but one thing I can tell you, if you, in case of a Cartesian system, you can easily visualize the fact that three walls, one, if you any consider any two walls, and you see, now you can see me. Okay, so in this situation I cannot show you the visualization. Okay, even if you see me, so if it is a offline mode, I will definitely show you. Okay, so now in case of a cylindrical and spherical system, if it is a offline mode, then I can able to see you. What was the reason? However, in case of these three linear planes, in case of Cartesian system, you can easily visualize. Those three are orthogonal to each other. Orthogonal means 90 degree to each other. Now, second condition must be, the second condition I am now writing. unit vectors must be orthogonal. Now, what is unit vectors? Now, if you uh, say for any vector, it is general conception. If you have any vector A, it has got two components. One is magnitude, another one is direction. Now that direction part is defined by that unit vector AR cap, or maybe some people use different notations. So this magnitude part only tell you the magnitude of that vector, and this unit vector part will be telling you the direction of that vector. Okay. So unit vectors are basically, its magnitude is 1, but they are important in case of a vector in order to understand what are the original directions of any particular vector. Okay, in which direction they are locating. Now, uh, in a in any case, we have, let us write it down now. In any vector, in a general vector, general representation of any vector is written by a1 e1 plus a2 e2 plus a3 e3. Okay. Uh, what is a1, a2, a3? You know, in any coordinate system, there are three directions. In any coordinate systems, there are three directions. So a1, a2, a3 are the magnitudes of individual directions. A1, A2, A3 are the magnitudes of individual directions, and E1, E2, E3 are the unit vectors along each direction. So if you say for Cartesian system, if you say for Cartesian system, if you say it is for Cartesian system, this representation can be written as A is equal to your first component x direction. Your first component is x. Okay, your first component is x, then y, then z. So this representation can be written as ax small ax cap small ax cap. Then next term will be ay small ay cap, then az small az cap. So this is the specific representation of a vector in Cartesian system. Okay, so if you now see this ax, ax, ay, ax, ay, and this az, these are the magnitudes of respective direction. Any doubt? I have
No,
heard some
no, sir.
noise. Okay. So AX, AY, AZ are the magnitudes of three directions respectively. Along AX is the magnitude of that vector along x direction, magnitude of vector or along y direction, and Az is the magnitude of A along z direction. Okay. Now this AX cap, this AX cap, AY
Unit
cap,
vector.
unit vector along respective directions. These three vectors, these unit vectors along three respective directions. Okay, Ax cap, Ay cap, Az cap. Now I am coming to the directions of the unit vectors later on. Let us finish the first part. Now the second system is cylindrical. If you say the cylindrical system, so the same vector can be represented as, the same representation can be represented as, it is the vector A. It will be the first component in the cylindrical system is R. So it is AR, AR cap, AR, AR cap, plus second component is phi, A phi, A phi cap, and the third component is Z. So AZ, AZ cap. Likewise, in the previous case, here also three vectors is represented by red, highlighted by red. This AR, A phi, AR, A phi, and AZ becomes the magnitude of the respective directions along R phi Z, and this becomes AR cap, A phi cap, and Az cap are the unit vectors along three respective directions. Okay. Now, if you come to the last one, in case of spherical system, so your vector representation would be, your first component in case of a spherical is R, so it will be AR, it will be AR, AR cap, plus A theta, A theta cap, plus AZ, AZ cap. So now you can see this like the same way, three different components are theta, no, this one not Z, it will be phi. So this is phi. So the highlighted by red, this will be the magnitudes. Highlighted by red, it will be a magnitude AR, A theta, and A phi, and highlighted by yellow, it will be the unit vectors along the respective directions r, theta, phi. So these are the representation of a vector in respective three directions. So a vector must have two components, one magnitude and one is directions. So this any vector can be represented in three representation. So is it okay with you till now, everybody?
Yes, sir.
Yes, sir.
I have shared you two notes, na? One note or
Yes,
two
sir.
notes?
Two
Two
notes,
notes,
sir.
sir.
Two notes.
Two notes. So in the second note, you will see that. Let me show you. In the second note, you see. In the second note, you will see that this at the starting, you see this a table is given. You see the general expression of a vector can be stated as it is written as a1 e1 plus a2 e2 plus a3 e3. So what is the definition of a1 a2 a3 and e1 e2 e3 in respective coordinate system are all mentioned here. Okay, are all mentioned here. So whatever I have written here in this slide, so all things are mentioned in a tabular form. Okay, all things are mentioned in this tabular form. You can go through. You can go through. It will be clear to you. Okay. And now let us coming about the directions of unit vector. So it is very important to know what should be the directions of an unit vector. Let us say now, uh, if you say, let us say this is our floor. This is our floor. Okay. You forget about alpha, beta, gamma for the time being. If you forget about alpha, beta, gamma, so let us say this is our xy plane. Now, what is xy plane? What is the definition, mathematical definition? Can anybody tell me? Previous day I have told you. What do you mean by xy plane? Mathematically. Anybody? This plane? So it seems you are not going through the notes. You are not following the class. Anyone? At least give a try.
The Z
Slower.
constant হয় XY plane হয়
Z constant and x and y are variables.
ভেরিয়েবল হ্যাঁ
Z constant, x and y are variables. So in this case, let us say you assume, or you please think of your either floor or roof. Okay, either floor or roof. Now in this case, this you see this x is variable. This x is variable. At the same time, y is also variable. However, z is constant. Z is placed at a at a particular height. So now, first of all, what will be the unit vector of the surface? Can you tell me? Constant. It is z equals to constant surface. That is okay. This is equals to z equals to constant surface. Now, what do you think? What do you think it is characterized by ax, ay, or az? Which one? Which unit vector? Ax, ay, or az? It must have some directions. This surface must have some directions. Okay. So what should we, in order to understand the direction, what should be the notation, correct notation for this? Ax, Ay or Az? Anybody, any idea? Okay, can you move a floor? Imaginary, in your imagination, can you move a floor? Am I audible? Yes, you can. If you cannot able to move your floor, then no buildings will be there. No buildings will be there. If the conception of moving a floor is not there, then you cannot build the buildings. Of course, it can be moved. It can be either lifted in the upward directions or it can be lifted along downward direction. These two, please give me 1 minute time. Are you there? Okay. So I was talking about of lifting a plane, or maybe more specifically saying about floor, whether floor or any roof, that is technically saying it is a constant jet surface. Constant constant jet surface. Constant equals to jet equals to constant surface. So I am telling about it can obviously be lifted either in upward direction or downward direction. That is why this conception uh, is there. So unless without this, no building will be created. So in building, what happens? Step by step, one roof. The first floor roof is built. After some time, then second floor is roof of the second floor is built. So in this way, first floor, second floor, third floor, fourth floor, and so on, it is built like this. So you see, it is either can go in the upward direction or it can go in the downward direction. So same for this any surface, any walls, it can either be traverse inside the room or it can be traverse outside the room, any wall. Okay. So in this way, you can imagine that any surface can be transferred, can be traversed either in forward direction or that will be in the reverse direction. So unit vectors will be just unit vectors are there just to indicate what direction it can move. Unit vectors are there to indicate what directions they can move. Now you can see z equals to constant surface, this roof or floor, whatever it may be. Now you can tell me in which direction it can move. You just tell me that in which direction it can move.
Sir, is it?
Along z directions. Okay, along
Yes,
x
sir.
direction. So whether if it is moves along positive direction, it must be a z cap, and if it is uh, moving along downward direction, it must be minus a z cap. Minus a z cap. So now the convention is that unit vectors must be orthogonal to each other. The conventional direction for the unit vectors is always along positive direction. Is always along positive directions. Okay. So if you see, this is x, ax cap. If this is ay along y directions, and if this is az, you can understand from your room. You see these three vectors are always orthogonal to each other. These three vectors are always orthogonal to each other. Having said that, I express my grievance not to make to understand regarding the remaining two vectors how they are orthogonal, but I believe you can understand these three unit vectors are orthogonal. You can understand that. So in case of a Cartesian system, Ax, Ay, Az, these three unit vectors are orthogonal and they will be directed along the positive directions of respective variable. Ax is directed along Ax, if this is the figure for Ax, A is directed along positive x direction. This is Ax, this is the direction for Ax. Ay is directed along positive y direction, and Az is the positive z direction, is directed along positive z direction. Similarly for cylindrical system, let me clearly draw the diagram first. One minute. Are you there? Hello. Actually, I am sorry for repeated interruption. Actually, relatives have come to my house, so this is happening again and again. So let's coming back.
No problem, sir. No problem.
Okay. Please be patient. Keep. So let us say this is x, y, z. So this is p, this is r, this is phi, this is z. So we have projected a point. We have projected a point on xy plane. We have projected a point on xy plane like this. So this is phi, this is r, and this is z. This was the original definition. So AR dash, that will be in the positive direction of R. So AR must be directed along in this direction. AR cap. Now phi, you see phi is starting from positive x-axis and it is getting incremented in this direction. It is getting incremented in this direction. Okay, in this way. So positive direction of a phi is will be in this direction. A phi. Okay, this is AR cap and this will be A phi cap. This will be A phi cap. And similarly, this AZ will be directed along in this directions, AZ cap. Okay, so again, it is difficult to make you understand how this will be how these three will be orthogonal to each other, 90 degree to each other, but it will be if it is an offline class, then I can able to show you. So for the time being, you consider this to one this set of unit vectors are also orthogonal. It's truly orthogonal. It's not any bluff here. So in case of a next one, in case of an spherical one, let me draw the diagram first. This is x, this is y, and this is z. So any point P, it is r,
Theta phi.
r theta phi. So in case of a spherical system, this is the r, this is theta. Okay, and this must be something around, something is like this. This is phi, this angle. So let me let me erase it for the time being. This is any point P is given by R theta phi. So now you see this is the theta direction. So this is the air cap. In this, you see this is the R. So this must be the positive direction of R direction. Okay, so this must be air cap. This must be air cap. Now this is theta direction along this way. Okay, along this way. So this must be the theta direction, a theta cap. And similarly this must be the phi direction. So it is again very difficult, even more difficult to make you understand how this AR, A theta and A phi will be orthogonal to each other, but it is, they are truly orthogonal. Do not worry about that. So please take that one for consideration. Again, I am telling you, if it is offline class, I would surely make you understand. Okay. So two questions, two conditions are satisfied. First one is those planes must be orthogonal to each other. Second conditions, unit vectors must be orthogonal to each other. Now I must tell final and most important condition. Uh, they must be, they must, or in a simple word, let us write, they must reflect right-handed system. Right-handed system. They must reflect right-handed system. What is right-handed system? Anybody can know? Do you know? Anyone? Anyone?
No, sir.
Okay, right-handed system is okay. So if you rotate, okay, in this small space, I must show you what is right-handed system for Cartesian system. So if you rotate AX, so this is for Cartesian. X, Y, Z. These are the three directions, respective directions. AX cap, AY cap, this is AZ cap. So now the right-handed system means if you rotate AX vector along AY vector, that means uh, this is a cross product, right? Cross product means you are rotating AX ax in the direction of ay. So you forget about z axis. So if this is x and y in a simple two-dimensional space, so ax cross ay. So if this is ax and if this is ay, so ax cross ay means you are rotating ax vector in this direction towards ay vector. Okay, in this direction means this direction, you know, this is the counterclockwise rotation, and counterclockwise rotation is considered to be the positive rotation. Okay, you know that, I hope. So ax cross ay, if you rotate like this, then it will generate a third vector which will be directed along az. Which will be directed along az. Okay. Again, if you rotate ay, if you rotate ay towards az in positive direction, then it will generate a third vector which will be directed along ax direction. And finally, if you rotate ay vector ax ay, sorry, ay, no, sorry. If you rotate az vector along ay direction, if you rotate az vector along ay rotation, ax, sorry, it's not xy, yz, and
ZX.
zx. So it will generate a third vector which will be directed along ay direction. So this is what we call right-handed system. So you just like on your wall, you are pasting a screw. You are pasting a screw. So you will by a screwdriver, you will rotate in a clockwise direction or anti-clockwise direction to press it, or to make it insert through the wall. You are giving a rotation in clockwise direction. So clockwise direction means what? You are giving clockwise direction means what? In this direction. Clockwise direction means what? In this direction. So if you giving this direction, clockwise rotation, then what will happening is that a third vector is generated. Which is directed along the direction which is acted through the wall. That means it is going through the screen of this laptop. However, if you giving the counterclockwise rotation, it will coming out. That screw will be coming out from the wall. That means it will giving a rotation, generating a motion or rotation, which is directed along the uh, in a direction which is coming out from the wall. So this is called the right-handed system. Ax cross ay. That means ax cross ay means it is counterclockwise rotation. So it will generate a third vector which will be acted along az. Similarly, az cross, it is ay. It is appearing at like AZ. It is not like that. It is AY. So AY cross AZ, that will be is equal to AX, and AZ cross AX, that will be AX. So this is exactly, it is called the right-handed system. It is exactly, it's called right-handed system. Now my question is to you, what will happen to this? What will happen to this if this is done? So this is called right-handed system. Okay. Now you tell me what will happen to this? Just one question. If you can answer this, you will understand the rest. AY cross AX.
minus AZ.
Y minus any physical interpretation. You are telling it is minus AZ. Your answer is right. But please,
Do you clockwise?
can you? Uh, yes. AX cross AY means you are going to give anti-clockwise rotation. So the resulting vector will be directed in a definite direction. Okay. But if you are doing this AY cross AZ, AY cross X, that means you are giving clockwise rotation. So that means the vector will be generated which will be just opposite to that AZ. It's just an example. I have stated you that a screw is you need to insert through the wall. To insert, you are giving clockwise motion, and to take it out, you are giving anti-clockwise motion. So if you changing the direction means what? One time you are doing AX cross AY, another time you doing AY cross AX. Okay. So if you are changing your direction, the resulting vector, the direction of the resulting vector will just be the reverse. It will be 180-degree phase aperture. Okay. So is it understood what is called by right-handed system?
Yes, sir.
Now in case of cylindrical system, I quickly write down those results. AR cross A5, AR cross A5, that will be given by AZ. A5 cross AZ, that will be called equals to AR, and finally AZ cross AR, AZ cross AR, that will be called A5. So this is called right-handed system in cylindrical system. And in case of an spherical system, it is AR cross A theta, AR cross A theta, that will be equal to A5. Next, A theta cross A5, that will be is equal to AR, and finally A phi cross AR, that will be is equal to A theta. So this is called right-handed system in spherical system. And like this one, if you change the direction, the resulting vector, the direction of the resulting vector will change accordingly. So now coming back to my initial question, so what is the guarantee that if today someone has come up with a new conception to introduce a new coordinate system, will that be a valid coordinate system or not, whether everyone will obey it or not? The answer lies in these three conditions. If any newly introduced coordinate system obey or undergoes these three conditions successfully, then it will be a valid coordinate system. It will be treated as a valid coordinate system unless it cannot be treated as a valid one, so it must be rejected. So with this, I am giving you a 1 or 2 minute break. You please, if you have any question, you can ask me now regarding this till now. Any question? Anybody? Please. If you feel any question, you can ask me. So, okay, if there is no question, we can proceed further. Last topic for today. So, previous day we have discussed about a point, how to transfer one point from one coordinate system into another. Last day we have discussed. Now, what will happen to that if a vector is there? Suppose in a Cartesian system a vector is there, you need to transform them in a cylindrical one or spherical one. So how to do that? So in this, the second note which I have shared with you all, there is equation 2 and equation 3 are given, in which this guiding formula is given. Equation 2 represents that how you convert a vector in Cartesian system into a cylindrical one, and equation 3 represents how you transform a cylindrical vector into a Cartesian one. Similarly, if the problem is shown, and same way, the from Cartesian to spherical and from vice versa, from spherical to Cartesian, the guiding formula is given. So you need to memorize them, or you need to learn them. And the best part of this, in today's online system, even if you do not know, no problem, absolutely no problem. Just at the exam, you can get access to the any formula and you can solve the problem. So equation 2 and 3 4 and 5 are important. So I am not deriving them at all. So you go through them and solve accordingly. Okay, solve accordingly. So I am not want to stretch it further for today. Uh, please raise a question if you have. Otherwise, I can end this class. If you have any question, I can answer them. Otherwise, I can end this class. If you have any question, please tell
No,
me.
sir. No, sir.
So your first module is almost over. Your first module is almost over. Uh, Very shortly, I will give you an assignment. You must solve this and submit it to me. Okay. So if you do not have any question, I can so end this class here. So let me stop presenting now. Let me stop recording.